Okay, welcome everybody. Here's our next lesson. We are going to do trigonometric graphs. So we've already looked at the graphs of sine and cosine. So first, let's just start with a quick overview of how we got these graphs. So I'm filming in a new location, so hopefully it looks a little bit better. Okay, so quick sketch of the graphs. Here's our x, our y axes. Next, remember, if we're let's do sine first. Okay, so for that, remember that the period for sine is 2 pi. After that, it repeats itself. The highest sine goes is 1 and minus 1. And let's make 2 pi over here. Remember the trick. Now we cut this up into 4 equal pieces. So cut 2 pi in half, pi. Cut this in half. Again, we get pi over 2. And then this will be our 3 pi over 2. All right, now what are the 5 key points we want to draw? So sine starts at 0. It'll be 0 at pi, and at 2 pi. 1 up here, and minus 1 down here. Now comes the wiggle. Nice and smooth. Okay, that wasn't that smooth. All right, that's pretty good. Okay, so there's our graph. Now, remember, this goes for forever, so it would repeat for forever that way, and it would repeat this way as well. So usually you'll just draw one period, but as I always say, draw a little bit extra and draw the little arrow to indicate that the graph continues for forever. All right, a quick sketch of cosine as well to review. Cosine of x. So these are going to be our fundamental building blocks for all of the other graphs. But these are really the most important. So really spend a lot of time on 6.3, as much time as you need to really master for yourself these graphs. Because again, I know how to draw them. So it might seem like I'm going very quickly, but that's because I've learned this material. And obviously I practice it every single time I teach the material. So don't feel like you need to do it as quickly as I do, because that's just not fair, right? I've practiced it a lot and you haven't, so let's not compare each other. But don't worry, you're going to beat me eventually, because you're going to practice these a lot yourself as well. All right, so we got 2 pi, we've got pi. Remember, cosine also has period 2 pi. So the trick to graphing these is, remember, draw the period, draw the maximum and the minimum. Cut this up into 4 equal pieces. Now cosine starts at 1 and ends at 1. In the middle, we're going to have -1. And at these kind of quarter markings is when cosine is going to be 0. Okay, so let's draw the best looking cosine that we can. Okay, that's not too bad. Okay, as before, this actually repeats itself, so let's draw maybe a little bit more on this side, a little bit more on this side. There is our graph of cosine, and the red part is the kind of the main part. However, it goes for forever, because as we talked about, the domain of sine and cosine are all real numbers, which means that we can graph all the way along the x-axis for as long as we want. Fantastic. So there are our basic building block curves. So what we'd like to do is we'd like to come up with graphs for the other trig functions. So we have 4 more to do. I would say tangent is the most important, and I usually kind of think of sine, cosine, and tangent grouped together. So maybe what I'll do is let's add y equals tangent x here, and then maybe next class, or next video I should say, we can add this picture to the group here, because these are kind of the 3 main building blocks. All right. So what's next? Next, I want us to just do a quick review of just some other pre-calculus ideas that you've seen before. So let's review what asymptotes are. And I like to write the shorthand VA for vertical asymptote and HA for horizontal asymptote. So let's just draw some pictures here. So if I have a coordinate grid, and if I want to draw something with an asymptote, let's start with a vertical asymptote. Here is the graph of a vertical line. Let's say it's at x equal to a. Well, if I have a function with this vertical asymptote, that just means that the function is going to not be defined here, but it's going to approach this dashed line. And then it can approach it in two different directions, or it can approach it in the same direction. A horizontal asymptote, let's draw a dashed purple line, and let's make it at the x-axis. Then our graph approaches this line like this. So this graph that I've drawn has both a horizontal and a vertical asymptote. And in this case, it's at the point y equals b. Now, of course, in the picture, I've drawn it at y equals 0. Now, okay, so the key difference is, of course, the x value. As I approach this x value, I'm basically either having the value of the function get really, really big or really, really small. And the horizontal asymptotes are when I look at the x values getting big, that's basically says move to the right, the y values are getting close to b. All right, so you're going to study these a lot in calculus, so it's kind of good to review these. Just going to give you a heads up. Next, I put these two remember, I like to call them memorable functions because there's 11 functions that you should know the graphs of purely from memory. So let's actually go to Canvas real quick. And if we go to, so this is just our module, so I'm using the iPad so it looks a little different. But if you see under handouts, you see I have a few good formula sheets selected. It'll look like this. I have a bunch of them for you to look at. The one I think is relevant right now is the graphs and identities. And this is what I call the 10 memorable functions. So I can't draw on this, but let's see, let's count them. There's the identity, y equals x. We know what that looks like. Y equals x squared. Y equals the square root of x. Y equals the cube root of x. Sorry, x cubed. That's this one. And then y equals the cube root is next, and etc. So look at the reciprocal, 1 over x. That's the one that has the vertical and horizontal asymptote. But there's more that I think are important. The other two important ones are the absolute value, e to the x, and natural log of x. So you studied those in last semester's course. All right, now there's other stuff here, but this is what we're learning right now. So notice that it goes to sine and cosine, and now you know exactly how to get these graphs. And don't look at the new ones just yet. All right, let's go back. So that's where I'm kind of grabbing these. So quick way to remember 1 over x squared is it's this shape called a hyperbola. 1 over x squared has asymptotes. I'm sorry, 1 over x. Let's start with this one. This one, it basically has a hyperbola like that. Now, 1 over x squared, because the y values are squared, they're actually all going to be positive. So we get this kind of shape. And I like to call this the Atari symbol, since there was this old video game console called Atari. They both go up. All right, cool. So as a reminder, how do you actually find algebraically the asymptotes? Well, that's what I have as a tip over here. So the examples are, if you're looking for 1 over x, where is the downstairs undefined? And it looks like 0 for both of these examples. Now, what about the horizontal asymptotes? Horizontal asymptotes, it's actually going to be 0 as well. And how you get that is you basically count the degree. So the degree on the bottom is bigger, and when the degree is a bigger number on the bottom, that gives you that the horizontal asymptote is y equal to 0. All right, cool. So let's build the graph of tangent next. But before we do, let's think about their periodic properties. So for tangent, it's going to have a period of pi, and you've actually heard me mention that before. Okay, now let's think about why. So we have the proof written down right here. It says, okay, draw a unit circle. All right, why don't we actually just follow along here? It says draw a unit circle. Okay, plot the terminal point at P1. Let's say this is P1. And then our T is going to be this arc length corresponding to T in quadrant 1. Then if P2 is the terminal point that corresponds to T plus pi, what would that look like? So let's think about that. Pi, remember, is half an arc of a circle. So if I actually want to do T plus pi, what I actually need to do is so check this out. This is cutting the circle this way, and I need to actually do half of a circle from T. I need to add pi. Where are we going to end up? We are going to end up over here. This is going to be our P2. So check this out. So notice that if P1 has coordinates x, comma, y, then P2, so if you look at the symmetry of this problem, you can see that, well, the x coordinate, instead of being, positive number here, we actually have a negative number. And the y value is also a negative number. So the coordinates of P2 are actually just negative x, negative y. You actually call this symmetry across the origin, if you remember that when we talked about all those reflections in 110A, or in Calc 1, or Pre-Calculus Part 1. Okay, so that's actually interesting. So what does this have to do with tangent? Well, now let's bring it together with tangent. Tangent of T plus pi. Let's think about what that means. T was this arc, that's the orange arc. Pi, remember, is the purple arc, half of a turn. If I do T plus pi, it's both of them combined, so I land at my terminal point, P2. So based off of this definition, I look at the y coordinate, negative y, negative, and then look at the x coordinate, and it's negative x. Because both of them are negative, notice that those minus signs cancel out, and I get y over x. Y over x is the same thing as tangent at pi. So I know that I have it typed out, but it's such a cool little argument, and it really helps to reinforce the drawing pictures is going to really be important for your development of trigonometry. Okay, cool. Now let's look at what it says here. It says that for cotangent, it also has period pi. So let's actually make that. Remember, T was the symbol we use for period. So for tangent, we have pi, and for cotangent. Now, why is that true? Well, basically, if it's true for tangent, just flip everything for cotangent, and same thing. So the key here would be that the terminal point at T plus pi is still this point. So if I want to build cotangent, I do negative x divided by negative y. The minus signs cancel out. All right, so what's next? Let's think about the period for secant and cosecant. Notice these, the formulas tell us, are back to 2 pi, because the period for sine and cosine were 2 pi. Now, this time I'm not going to draw a picture, but let's basically reason through it since we already have the picture here. So secant of t plus 2 pi is by definition 1 over, oh, and I made a boo-boo here. You can see that there's a typo. This should say cosine. 1 over cosine of t plus 2 pi. And of course, cosine of t plus 2 pi is 2 pi periodic, so the same value as cosine of just t. And remember, what is the reasoning for that? So if I'm adding 2 pi, let's see, can I use a different color? Let's use this bright green. Here's t, cosine of t would be just x, but if I add 2 pi, I basically add that full bright green thing, and I'm back to where I started. So cosine of this new number is the same as the original. All right, and then the thing for cosecant is pretty similar as well. So these are really important. Let's maybe put some stars. I do like the green and purple. It looks really cool. Okay, so there are the periods for tangent and cotangent, secant and cosecant. So now you know the periods for all of the 6 trigonometric functions. And remember, what is the period? That is the segment of the curve that is going to repeat itself. The reason that they repeat themselves, I'll remind you one more time, it's because they're based off of the unit circle. And as you keep wrapping around the unit circle, they are going to repeat the same values. Okay, so here is, without further ado, the graph of tangent. So it's already kind of, I started with a screenshot from our book here. So you can see that, let's actually write out tangent y equals tangent of x. Remember, the reciprocal identities tell us that this is sine of x divided by cosine of x. So this is kind of the fundamental idea for coming up with this graph. I'm going to think of it as, I know the values of sine and I know the values of cosine, and I'm going to look for some special values and we'll come up with them. Now, let's start with these key pieces right here, these asymptotes right here. So at -1/2 and +1/2, I have vertical asymptotes. Now, why is that? You can see this picture again right here. Think about it like this. Well, when is the downstairs part of this fraction equal to 0? When I divide by 0, that's when I make something undefined. So that's the big no-no. So cosine of x equal to 0 is bad. Let's put the dangerous curve here. So for what values of cosine, so for what values of x is cosine equal to 0? So if you look at a unit circle, I'll just use this one since it's right here. Cosine is equal to 0 at the top and bottom of the circle. So those angles are pi over 2 and 3 pi over 2. But if it's actually better to just think of it as pi over 2 and minus pi over 2. So that's where those actually come from. Another way to look at it is, since we have the graph right here, where is cosine equal to 0? Right here and right here. So let's write that down at x equals to pi over 2 and 3 pi over 2. Now remember, we can actually represent the same location using different radians. 3 pi over 2 is the same as negative pi over 2. Cool. All right, so that is why we have these asymptotes. So now I have a bunch of stuff I wrote here as observations. Let's kind of read through these before we draw our own version of the graph. So we know that the domain of tangent is pi. I'm sorry, the domain is all values of t where t is not a pi multiple of pi over 2. Okay. So it's undefined when cosine is equal to 0, so we basically have to avoid these, and that's why when you look at the graph here, if I shift pi over 2 by pi, so if I add pi to 3 pi over 2, that's 3 pi over 2. Sorry, I said that wrong. I already did the calculation in my head. So if I add pi to pi over 2, then I'm at 3 pi over 2. So, okay, that's how we can get all of the other asymptotes. So it's, quite a bit of work. So I'm just relying on the graph here to kind of explain it. Okay, so we have vertical asymptotes. The reason we have those, again, is because we're dividing by 0 because cosine has 0 value at these things. All right, the other thing that's kind of neat is, remember this concept? We talked about one-to-one functions. That means that they pass the horizontal line test. So I've drawn some horizontal lines, and as you look through it, notice that I intersect the graph only once. So that's what it means to be one-to-one. Okay, so let me draw my asymptotes again. So that's going to be important in a later section, but for now, just kind of put that aside, put it in your cache memory. Okay, the next thing I want to talk about is the principal branch. This is an important idea here of tangent. For sine and cosine, since they're defined everywhere, basically they'll just repeat over and over and over. You'll get the wiggle, and it'll just wiggle and wiggle, wiggle, wiggle for forever. Tangent, though, is a little different. Tangent has kind of asymptotes. So you have to basically draw one nice piece here, and then you have to hop over the asymptote and then draw another copy of it over here. And then, of course, you can hop to the other side as well. So what we call this middle one, we call this the principal branch. It's basically the one that passes through the origin, and it has the domain, I'll write it like this, minus pi over 2, comma pi over 2. The reason why this is so helpful is this one's actually, if I look at it, it's kind of a complete curve on that domain. All right, so now I know that we have the graph right there, but what I'd like to do next is actually just build this graph by hand. Okay, so let's do that now. So let's write first y equals tangent of x. Let's write this as sine x divided by cosine of x. All right, we're going to draw our coordinate grid here. X, y. For this, what I'm going to make a note of is I'm going to write that D for domain. The domain is all x that are not equal to pi over 2 plus pi times an integer multiple, so we write it like this. There's our domain. The other way to think about it is, well, what I'm going to do is I'm going to start by basically drawing the vertical asymptotes as the very first thing I do. Minus pi over 2 here, pi over 2 here. And let's highlight that so you can see the values. So I'm already basically scaling my x-axis by using pi over 2 and minus pi over 2. So, sometimes you'll see me not write it again just because it seems redundant and the picture gets a little messy, but there it is. We'll do it this time. All right, so those are the values. Those are the asymptotes, so we can't draw points on these red vertical lines. But what about the points we do want to plot? So again, everything boils down to a unit circle at some point. So let's think about a table of values, and let's think about if I plug in x for y, and in fact we should probably think of it as t comma tangent of t, which is going to be sine of t over cosine of t. I know it's a little annoying to keep going back to t variable, but it pays off, I promise. And then we want to think about, okay, as I plug in different values of x, what are going to be the special values for tangent? Certainly, we can evaluate it here because this has points 1, 0. I can't evaluate it here because I would do 1 divided by 0, and that's undefined. I can't define it here. So let's actually put these ones as little red markers. So we're actually going to draw it for values of t that are in this part of the unit circle, the right-hand side. Because think about it, that's going to be from minus pi over 2 to positive pi over 2. 0 is in the middle. So that's kind of the connection between, here's my length. If I stretch out my noodle to the x-axis, then those are the same. All right, but So far, basically, if I do tangent, which is y over x, so 0 divided by 1, well, I can evaluate that and I get 0. Okay, so I've got 1 point. Something. The next thing is like, okay, remember we've got 3 whiskers to work with where we know the coordinates of the point on the unit circle. Now for tangent, the only one I'm actually going to work with is this pi over 4. Now, what were the coordinates of pi over 4? Remember, pi over 4. The coordinates are root 2 over 2, comma, root 2 over 2. Now, to build tangent, we do y over x. So that's root 2 over 2 divided by root 2 over 2, and those are the same numbers, so I get 1. So at pi over 4, which is halfway between 0 and pi over 2, I'm going to get 1. So let's label that 1, and let's put a blue point right here. So there's only going to be one more point I recommend sketching for tangent, and that's going to be minus pi over 4. So if we look at the whiskers, I'm thinking of this in negative radians here, so from 0 to negative pi over 2. The whisker I want to work with is actually negative pi over 4. Now, in this case, the y-coordinate is now negative root 2 over 2 because the y-coordinate is below the x-axis, but the x-coordinate is still positive. So I'm just going to get negative 1. So these are the 3 key numbers that I recommend you sketch for tangent. So again, we're going to cut the distance between negative pi over 2 and 0, cut that in half, and then we're going to plot our point at negative 1. All right, and then from here on out, why does the shape look like this? Okay, so mine looks a little bit more like the right one, the way I've scaled everything. So let's think through this. Let's kind of use a little bit of a logical argument. Let's start with just this positive part. So I'm going to imagine the t value going from 0 and increasing to pi over 2. Okay, so actually, I don't want to cover up my picture too much. So t is going to go from 0, increase to pi over 2. So I want to make that slanted arrow to designate increase. So what's going to happen to tangent? So this is a lot trickier, right? We have to basically, in our brains, calculate, okay, y divided by x. So the y values, as I'm in this kind of lower part, are very close to 0. And the x values are very close to 1. So it's basically going to start off kind of being to 0. As I increase to pi over 4, they're basically the same. So it's going to do something like, oops, yeah, I'll keep it purple, something like that. As I keep going forward, though, I'm basically going to get that the bottom is getting really, really big numerically, but the top is only approaching 1. 1 divided by 0 is approaching infinity, so that's where we get this. Now, let me, this is a little bit of a preview of calculus. 1 over infinity, I'm going to put quotes because it's not like a number, and this isn't a real equal sign. This is more like a conceptual thing. So why is that true? So if you think about 1 dividing it by a tiny number, let's divide it by like 0.1, for example. If you do this on your calculator, you'll get 10. Let's do another one. Let's divide it by an even tinier number, 0.001. If you do this on your calculator, you'll get 1,000. And the pattern would continue. So if I divide it by an even smaller number, well, I'll get an even bigger number. So what we're saying here is that as my x value is going to 0, as I move up along this arc here, the tangent, which is sine over the cosine, will get really, really big. I know that this is a lot of ideas. Oops, erased too much. So just see if you can think through it. Ask me questions in class if you want maybe a further explanation. But basically, if all you do is just remember that those are the 3 points you can figure out exactly, and you know that you need to have an asymptote, you know, well, from here to here, I'm going to go up, and then I need to try to hug my asymptote, so I'm going to just do that. And then I need to go down and kind of try to hug my asymptote, and notice I'm putting little arrows at the ends of everything because the graph keeps going for forever. Okay, cool. There's the graph of our tangent, and now let me box it maybe with some highlighter. So it looks nice because we kind of did a lot of scratch work on the side. And this, maybe I'll shrink it. Okay, I don't know why this is bugging out on me. I think, excuse me. I think my iPad just gets a little tired. Let's see if I restart my graphing program. All right, I think I'm recording again. I don't remember where I left off. I am very sorry. As I said, I'm not a professional video maker here. So maybe some mistakes are going to happen. All right, let's see. What I really wanted to do was just resize this, but then oh, there it goes. It just was bugging out. I'll keep it here, but just make it really tiny. Wasn't the most important part that I wanted to do, and what I wanted to do was just to, oh, what happened here? I think I want my iPad. What's happening here? Sorry. Hang. Oh, okay. We're back. Okay, cool. Everything's back in order. All right, so let's keep going. Let me double check that the video is rolling. I'm sorry, this must be terrible to watch. Watch me fumble with technology. Okay, we're rolling. All right, let's keep going. So we've got the tangent graph. Now that we've built this very slowly, let's go back here and add it. And let's add it quickly. So what were the key features of tangent? Well, let's start with the asymptotes. Minus pi over 2, positive pi over 2. Those are very important to remember, is where the asymptotes are at. Next, the 3 key points. So, oops, we're going to go up 1 and minus 1. So for tangent, the key points are going to be 0, 1, and minus 1. Okay, so there's our graph of tangent. Now, since I do want to make them look like they go for forever, all I'm going to do is just essentially keep adding some asymptotes. Let's add maybe just two more of them, and then just copy the basic shape. I know that they're not going to look perfect because these are hand-drawn, but I think drawing things by hand is very powerful, and I really encourage that you're following along, trying to draw them yourself. Of course, hit pause on the video, try to draw them nicely. You'll get better as you practice. All right, so what's next? So now we've got the graph of tangent. Next up will be cotangent, and this one I'm going to I was going to let you guys do it, but let's do it together. So looking at this graph here, notice that it doesn't have minus pi over 2 to pi over 2 as its domain. It actually goes from 0 to pi. Okay? And the reason for that is because, of course, cotangent of x is going to be cosine on the top divided by sine on the bottom. So where is it going to be undefined? It's going to be undefined when sine of x is 0. So that's when we're going to have the dangerous points here. So going to our unit circle is, think of a really tiny one and a quick one. Where is sine 0? Here and here. So it cuts up my circle this way. So basically, I don't need to go from minus pi over 2 to pi over 2 because I have that big red mark x in the middle. It actually makes way more sense to just go from 0 to pi over 2. Sorry, 0 to pi. That makes perfect sense. So it's actually a little bit nicer from that perspective. Now, what are going to be the key values for cotangent? It's going to be this value here right in the middle, and then the 2 pi over 4 whiskers. And let's highlight it here. So let's get rid of this orange. So let's think about why cotangent at pi over 2, now this unit circle is very tiny, but so remember at the very top we have 0, comma 1. So for cotangent, we're going to have cosine is 0, sine is 1. So 0, 1 means we have 0. So that's why we have at pi over 2. The next two that we want to do is, well, what about pi over 4? So this whisker. Cosine and sine are the same value, so we're going to get 1. What about 3 pi over 4? That's going to be this marking right here. So this marking on this side. So the x-coordinate is negative, the y-coordinate is positive. So one of them is positive, one of them is negative, and I'm going to get negative 1. So those are the 3 key points. Then all you want to do is just add a nice wiggle here and add your red lines. All right, so let's do this a little bit slower, and importantly, we want to draw this one by hand. All right, so let's draw a quick little unit circle, a little bit bigger this time. Okay, so if we want to do y equals, cotangent of x, we want to think of this as cosine on the top, sine on the bottom. Okay, so where is this? What is the domain? It's the set of all values where sine of x is not equal to 0. Where is sine not equal to 0? Put the red x's right here. So the values that we're going to be working on are going to be from 0 to pi. And the nice values where we're going to evaluate it is going to be at pi over 2, pi over 4, and 3 pi over 4. Okay, so what are the values here? Let's just label the points. Root 2 over 2, this is going to be the easier one, 0, 1. And since I have the iPad, might as well take advantage. Let's copy and paste. And which one gets the negative sign? Cosine or sine? Well, it looks like the x-coordinate is negative, so that one gets the minus sign. All right, so if we're going to build a table of values, if we want to do x, what's wrong with me? Cotangent x, I'm going to plot in these points. So I can't plot 0, so if I put 0, we're going to get undefined or does not exist, but I'll just put it there. So we're actually going to start it with pi over 4, then we're going to do pi over 2, that's the middle, and then 3 pi over 4, and then the last value, pi, we're going to get does not exist as well. Those are what I'm representing as the x markings, because again, that's where sine is 0, and if sine is at the bottom of the fraction, it's undefined. All right, let's see. What is cotangent at pi over 4? So cotangent at pi over 4 is x divided by y, but those are the same value, so we get 1. What about pi over 2? We're doing x divided by y. That's 0 divided by 1, so that's 0. And then at 3 pi over 4, we're going to get x divided by y, which is going to be -1. So once we've got those nice values, we have our nice little sketch here of our x and y coordinate grid. This time, our asymptotes are going to be at x equals 0 and at pi. So I'm going to put the pi over here. Now I'm going to cut this up into fourths. Halfway marking is pi over 2, and then cut that in half and in half, and only mark the middle. It makes the picture a little bit easier to read. Okay, now I'm doing 0 at pi over 2. Notice that at pi over 4, I'm at 1. So I should definitely scale my axis, 1 and -1. And notice that at 3 pi over 4, I'm at -1. So tangent, remember, was basically going up. So this tangent, right? Tangent goes up. So if you kind of follow the marker, it starts down here and it moves upwards. Notice that cotangent, on the other hand, actually goes down. We're going to have to draw through this curve. So trying to draw my asymptotes while also passing through the points that we already labeled. There we go. Beautiful graph of cotangent. And if I want to draw more of them, I just kind of pretend. Okay, that's horrible. But, you know, these keep going for forever. Okay, I'm not happy with that. Let's maybe draw. Etc. Okay, not super good. Good enough. Again, I'm trying not to make these videos last for forever, and I don't have time to make all sorts of fancy editing. So we've really got to go with whatever I record. All right, cool. So pause the video. Make sure that you can practice drawing these from scratch by yourself before you move on, since, again, these are super, super fundamental, and it's going to get only a little bit tougher from here. All right. Pause the video. Okay. Let's keep going. So next, let's see what the graph of cosecant will look like. So for this one, let's kind of study the graph that's already drawn, and then we can draw it by hand as well. Because again, I'm a big believer of kind of doing it in our own writing. It's just staring at this graph. I mean, I don't know. I know what they look like, but you know, if this is your first time seeing them, you're like, oh, where did everything come from? It's important to just build the story. Excuse me. Okay. So let's take a look at this graph. And first, I want to draw your attention to the blue curve. Notice that it has sine of x is drawn for us in blue. If our goal is to come up with the graph of cosecant x, remember this was defined as 1 over sine of x using the reciprocal identities. And okay, what this means is we have to think about where it's undefined as well. Where is sine equal to 0? If we look at our unit circle, sine is equal to 0 here. So just like cotangent, we actually want to think about between 0 and pi. So we're going to have an asymptote here and an asymptote here at pi. Now cosecant actually has period 2 pi, so this one's actually funkier, because check it out. When I get back to pi over 2. So for this one, it's weird. It's like we actually have to hop over the bad point and do one full 2 pi drawing of it. So the trick for drawing cosecant is basically two things. You're actually going to draw sine first, and you're going to use the special values here and here. So there's basically just the two key points from sine that we want to look at are those two. Now, sine is 1 up here. Sine is -1 over here. Again, we kind of just drew sine already. So why do we draw these shapes? So let's think about that. So what sine is doing, if I think of it from the unit perspective, remember I want to think about you're going to have to kind of use your imagination here. What is happening as I move along this point? So sine starts out at 0, it goes up, and it comes back down. If I do the reciprocal of that, well, 1 over 0 is undefined, so I'm actually going to start at basically a really big positive number. As I basically go up, as the point goes up, I actually have 1 is going to get smaller until I get 1 divided by 1. So the smallest value we're going to get is 1. Now, as my point moves this way, the y values start to decrease again. So 1 divided by a tinier and tinier numbers is just getting bigger and bigger and bigger. So that's why we get this type of a shape. Okay, and now we have to do it again down here. So over here, as my y values are down here, they're negative and they're close to 0. A negative number close to 0 means we're going to start off in this part of the graph over here. So I'm kind of exaggerating it so you can see I'm down here. You know what, maybe I should sketch these in blue so that it's obvious what we were doing. So as I start over here, we're going to be negative and close to 0. Over here, the y values are close to 1, so we're going to be kind of close to 1 over here. And, I'm sorry, close to negative 1, because all of these y values on this part of the unit circle are all negative. That's why I'm actually always, notice that I'm always below the x-axis. Okay, so that's how I like to think about how this shape was created. And now let's add little arrows, add little arrows, add little arrows. Okay, so actually the graph of cosecant is both of these pictures. They look like parabolas, but they're a little bit different. They're not quite parabolas. Okay, so because this pattern repeats, let me actually do it in purple, you would actually, now I'm out of screen here, but you would actually get an extra piece over here, and then this piece would repeat over here. It's almost going into the next picture. So one of the things is like the one that we drew is actually missing the other half. This is this part here because that's from 0 to 2 pi. So that's something that's kind of neat. But some people prefer to draw it where they basically have this one going up and then this one going down, and they prefer to think of their asymptotes right here. Actually, there's 3 of them. So it's up to you which way you prefer to draw it. I prefer to draw it this way, so let's just kind of go over that, and I'm going to go a little bit quicker here as we try to come up with this graph. So I'm no longer going to try to use, I'm not going to do a table of values and all that stuff. I'm really just going to emphasize cosecant x, 1 over sine of x, and then what we're going to do is we're going to pick a different color. Let's do this blue here. And let's just draw a quick sine piece. Let's also draw the quick unit circle to remind us, okay, where is sine 0? Here and here. Those are going to be the bad points. That is going to give me a vertical asymptote every time sine is 0. So notice that I get 3 of them at 0, pi, and at 2 pi, which is basically back to 0. All right, then I'm going to plot a point up here, down here. Keep in mind these are 1 and minus 1, and then just remember that for cosecant, you're going to have asymptotes, so you just draw your best to kind of go towards these asymptotes here. And there you have it. So not too bad, I think. Let's do the last one, which is actually, hold on, one more thing before I move on. The slide I want to just highlight just for consistency, since that's what I've been doing. All right, now let's just skip all the details here and let's just jump straight into drawing secant by hand. Let's see how good we can do this. So we're going to start with our grid here. Start with a unit circle. All right, what are we drawing? We are drawing secant of x. What is the definition? 1 over cosine. Or I keep saying definition, but for us, I guess it's the reciprocal identity. All right, so since we're dividing by cosine, where is cosine 0? That's here and here, because that's where the x coordinates are 0 on the unit circle. Okay, that means I'm basically going to think about it as two pieces here and here. So where are those asymptotes? Let's put them at, okay, let's actually say this is pi and 2 pi. That means our asymptotes are going to be right down here. Okay, I need to draw a little bit better. I'm trying to go quick here. So we have pi over 2 and 3 pi over 2. All right, so let's also draw in a quick cosine. Cosine goes from 1 to -1 in this way. Starts at 1, ends at 1. In the middle, it's going to be at -1. So there's our graph. All right, and for this one, let's start in the middle down here at -1. Follow your asymptotes. There's our piece. Now for this piece, I need to go from here, approach my asymptote, so do your best. And I can go like this and approach my asymptote. So for secant, it actually does get kind of chopped up, and this is the way I prefer to draw it. Of course, if you really want to, you can actually go to -pi over 2, that's this side here. And since you know what cosine looks like, it just does that. You know that this piece, and let's draw it in light blue, would go like that. But cool. Not bad. Now you've got all of your 6 trigonometric functions visualized as graphs. Nice job. All right, so before I do this section, let's let me actually open up the previous section for a little bit and just review what was it that we were doing. So as we looked at this piece here, what we were really looking at is, okay, I guess the highlighting is getting a little out of control. These two functions. Now, they're based off of sine and cosine, but what we've done is we've actually done some extra transformations. So we're kind of changing them and manipulating them. And if you watched the video from the previous section, we know that some of these stretch or compress the basic shapes. Sometimes they pull or compress in the y direction, and sometimes they're just basically shifts to the left, to the right, or shift up and down. All right, so, you know, this is definitely some of the harder stuff in this chapter, is practicing how to sketch these. So please, I recommend you try to do as much of the homework from this section as you can, because drawing the graph, the transformed graphs, is pretty challenging. All right, so back to our 6.4 section. So back to this. It says graphs are transformations of tangent and cotangent. So now that we know that tangent and cotangent, now we're going to just jump straight into the full-blown transformations. Okay, and let me remind you that the periods for tangent are pi. So notice the formula here changed. In the last section, it was t equals 2 pi over k, because sine and cosine have period 2 pi. Tangent and cotangent have period pi. So the formula is now pi divided by k. All right, so with these things out of the way, let's draw y equals 3 tangent of x. And again, all of this is going to be done by hand. So why don't we start and draw a quick sketch of tangent. So we're going to have asymptotes. Since I just did this, I remember it, minus pi over 2, pi over 2. If you forget, draw a quick little unit circle. Tangent we're dividing by cosine, so I want to avoid those two spots. All right, now tangent, plot this, 1 minus 1, something like that. Okay, actually I want to plot this in a lighter color. So there's tangent. So what does multiplying tangent by 3 do? That, remember, was a vertical stretch. So we're going to stretch out tangent. Now, what I want you to pay attention to is, remember the x values that we plotted are basically 0, pi over 4, and minus pi over 4. So what I'm going to draw is, instead of being at 1, I have to stretch it. So I'm actually going to, instead of 1, I'm going to be at 3. And instead of minus 1, I'm going to be at minus 3. So check this out. Instead of 1 here, I'm stretching it up to 3. 0 times 3 stays at 0. And then minus 1 gets stretched to minus 3. So what we end up doing is we end up stretching it, and it's really hard to really appreciate what's going on here, because it doesn't look that dramatic because the shape wasn't that dramatic as well, but we're really pulling the tangent and stretching it by 3. So there's our graph in blue, y equals to 3 tangent of x. All right. Let's see if maybe I can copy, and let's get rid of this 3. This time we want to know what happens at minus tangent. So let's delete that. Okay, so minus 0 is still 0, so that blue point in the middle doesn't move. But what is going to happen is, remember, multiplying a function by a minus on the outside of the parentheses of x, it's a flip. So it reflects across the x-axis. So what we're going to do is this point moves up. It gets flipped over here. This point gets flipped and moves down, and it comes down here. So this one is like this in dark blue. Cool. So those weren't too bad. Moving to the next examples. Ooh, and you know what I just realized? I should just keep copying my tangent. All right, so what are we doing for this next example here? So we have tangent of x over 3. So this time we have that the k is 1/3, so we have to figure out what the period is. So t is pi over k, pi divided by 1/3, we use the flip trick, 3 pi. So what this is telling us is, instead of having period pi, we are actually stretching out tangent. So right now, if you kind of think of this shape, tangent's going to be like kind of wider because I'm stretching it horizontally. So it's going to look something like that. All right, so what I'm going to do is I'm actually going to delete my asymptotes in red. Leave the original tangent just so that we can kind of compare it. But watch what's going to happen. So this was originally pi over 2 and minus pi over 2. But what we want to do now is we're going to basically, our period is 3 pi. So before, this length was pi. From minus pi over 2 to pi over 2, if you add those lengths together, it's pi. Now what I need is I need a period that from here all the way to here is 3 pi. So if you actually think about it, 3 pi divided by 2 is just 3 pi over 2. Which means that is what I'm going to do over here. And then it's going to be minus 3 pi over 2. So if you add this length from here to here, add 3 pi over 2 plus 3 pi over 2. So you're going to get 6 pi over 2. 6 pi over 2 cancels and gives you back 3 pi. Perfect. So that's the period. Now let's draw our asymptotes. So, and I'm going to do a horizontal stretch. So basically at the halfway mark, I'm going to be here. And at the minus halfway mark, I'm going to be right here. So notice that the y values actually stay the same. So I'm basically just stretching it horizontally. All right, so there's our graph of tangent of x over 3. Cool. And let's tag part B as a GTQ. And what I'd like to invite you to do would be to pause this video, see if you can do this one on your own, test your knowledge, and if not, that's okay. Hit play when you're ready, and then we can do it together. Ready? Let's go. So here's the graph that we want to look at. Y equals tangent of x over 3 minus pi over 2. So for starters, why don't we just kind of get it in the right form first? So to do that, I'm going to actually factor out the 1/3, and then I'm going to write this as parentheses x minus parentheses. So what's the piece that I have to have in the space that's missing? So I need basically 1/3 times mystery, and if I multiply those together, it should give me pi over 12. Right, because that's what we would get is if we went back and we FOILed, so distribute those. Okay, so did you figure it out? Did you get pi over 4? If so, fantastic. And if not, let's check. So distributing 1/3 times x gives us x over 3. And then 1/3 times pi over 4. Multiply the tops, multiply the bottoms, you'll get pi over 12. So cool. Now, the reason for doing that is, well, remember, this is going to be the k. So we're going to get k is 1/3, which we already did this calculation. I'm going to skip it. The period becomes 3 pi, and that's because of this right here. So let me just cite that. Pause the video if you want. Okay, so the period is 3 pi. What's this piece? This piece, remember, is what we call the b. B is pi over 4 because the minus sign is not part of the formula. So what this means is if it's pi over 4, we're going to do a horizontal shift to the right because pi over 4 is positive, to the right by pi over 4. So now when I draw the graph of tangent, I have to do two things. I need to shift it and stretch out its domain. So how do we do something like this? So here's how we can proceed. So originally tangent would be from minus pi over 2 to pi over 2, something like that. what we need to do is we actually need to shift. So let me actually draw them as straight lines, because trying to erase all the little dashes, I have to erase them individually. It's kind of difficult. Okay, so why don't we do this? Why don't we shift to the right by pi over 4 first? So, okay, if this is pi over 2, pi over 4 would be kind of these halfway markings. So let's draw them in orange as kind of a temporary draw here. So this is the shifted by the right. So this is, I need to add pi over 4 to this number. So hopefully you can do it without even doing any calculations. You can see that this is going to end up at minus pi over 4, and if not, then just add pi over 4 to negative pi over 2, and you'll see that they're the same. So to get this value, I'm literally just going to add pi over 4 to pi over 2. So what is that number? That's going to be pi over 4 plus 2 pi. So 3 pi over 4. Okay, so let's move this calculation over here. But now I need to stretch this by 3. So you know what? I think the easiest way to explain this is, let's get rid of this. And since I need to have period 3 pi, if this is kind of my asymptote, I'm just going to add 3 pi. And now where am I going to end up? I'm going to end up at 3 pi plus negative pi over 4. Because that's where I'm going to start from here. I'm going to add 3 pi to that. This is where I'm going to end up, and this is where I want to put my other vertical asymptote. So what is that? That's going to be 11 pi over 4. So I'm skipping the calculation this time. All right, so sometimes I do this kind of preliminary work. Now let me erase it, and we'll do it again, but neater, because now we know where we're going. All right, so remember, originally tangent has the left vertical asymptote at negative pi over 2, but we're shifting that to the right by pi over 4. That means that our asymptote is going to be at negative pi over 4. So now let's draw it nice and neatly. And I'll even label it minus pi over 4. So next we need to basically add the period. That's going to give us the right asymptote, which, let's do it. 3 pi minus pi over 4, that's going to be 12 pi minus pi, so that's 11 pi. And I'm just going to eyeball it. I'm just going to put it over here. Oh wait, I guess I can't. I've already scaled the left axis. That's negative pi over 4. So actually I have to count. 1 pi over 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whew, just made it. All right. So let's actually count the number of markings that we have here. I have 12, including this negative one. So I have 11 markings here, plus this marking gives us 12 markings. So what that means is I want to go 6 markings to be in the middle. 1, 2, 3, 4, 5, 6. So there's my middle. Let's put 1, 2, 3, 4, 5. So tangent, remember, is 0 here, and then I'm going to go up 1, subtract 1, and I'm just going to find, where's the middle? 1, 2, 3, 4, 5, 6, so 3, Go halfway, so 3 and up. Go halfway. I know my scaling's not perfect. Okay, so a lot going on in this graph. We're stretching it because the period is now 3, and we also shifted it. So we did 2 things, but just coming up with this graph was quite a bit of work. So, but it's a lovely, lovely problem, and if you can do problems like this, you are ready. That's how you know that you've mastered the material, is if you can do a problem like this. All right, so how much more? A little bit more. So I'm going to leave this cotangent one for you. Just to remind you, when you turn in the class notes, you don't have to do anything I put as you. Try it though, try them out. It's extra practice, but the minimal amount of practice is the ICA, so I do want to see those. All right, but let's do cosecant and secant with one of the transformations. So I think what we're going to do is this last one, I'm going to set it as a U as well. So we've got 2 more problems for us to work on, and then we'll stop this lesson for today. All right, so now what we want to do is consider the transformations of secant and cosecant. So remember that secant and cosecant have period 2 pi, so we're going to use this formula here. Also, let's go back and revisit what were the graphs. So here is the graph of secant. Drawn by hand. Here is our graph of cosecant. Drawn by hand. So we're going to want to have these pictures handy as we think about the next 2 transformations. And I'm going to actually skip this one as well. And let's just do this one, and let's tag this one as a GTQ. What did GTQ mean? Remember, that just means good test question. All right, so a lot to unpack on this problem, so let's take it step by step. First things first, notice that it's the graph of cosecant. So that's going to be what we're building on. So let's write it in its kind of standard form, which is kind of like these purple pieces that I've highlighted. Cosecant. Now I want to figure out the k, so we're going to factor out the 1/2 here, and then x. Now notice that the minus sign is part of the formula, so I'm going to rewrite this as a minus minus. All right, so again, 1/2 times x gives me x over 2. 1/2 times what mystery thing is going to give me a positive pi over 4. So it looks like I need a pi over 2. Right? Because 1/2 times a pi over 2 gives me pi over 4. Now I have 2 minus signs because those 2 minus signs make a positive, but the reason why I'm adding the minus signs is because they match the correct form for a transformation. Okay, so what are we going to do with this info? So first, let's start with the k. K is 1/2, which tells us that the period t. Now that we're back to cosecant, we're going to use the formula 2 pi over k. So our period is 4 pi. All right, our b is our shift is actually negative pi over 2. What that tells us is that we have a horizontal shift to the left, because it's negative, by pi over 2. So notice I'm not writing to the left by a negative pi over 2, I'm just saying left pi over 2. All right, so here's what we're going to actually do. This is kind of like the key idea for this. So what we're actually going to draw is we're going to draw 2 sine of 1/2 x minus a minus pi over 2. So this is back to the last lesson. And we are going to do this. Okay, so let's start with that. And because to draw cosecant, if you remember, we had to basically use the graph of sine to figure out how to do the graph of cosecant. So first things first, let's draw sine, and let's do all of our markings. So let's see. Our period is 4 pi, and we're going to shift to the left by pi over 2. So if this was our original graph, we're going to shift it to the left by pi over 2. So it's actually going to look like this. So that's to the left. Okay. And then I need to stretch it out. So the next part is now, instead of it being period 2 pi, it actually 4 pi means, let's see, here's 2 pi. Double it. So actually, let's do it this way. 0 to here, that's 2 pi. Visually, okay, there's another 2 pi. There's 4 pi total. And now we need to shift it to the left. Okay, so that's 4 pi in this kind of green. All right, so that's going to give us the domain. Now let's make it a little nicer looking. So what we're going to do is we want to so one way to do it is to figure out this kind of where this ends, this right end point here. It's just going to be, okay, I guess I need to stretch this out even further. All right, so this marking is actually just 4 pi minus pi over 2. So think of it geometrically, minus pi over 2, and then I'm going to add 4 pi in length. Let's convert that to a fraction. So let's see, that's going to be 8 pi over 2, 7 pi. All right, now let's get rid of this stuff. We don't need it anymore. It's just kind of there to guide our thinking. All right, so from there, what are the steps to draw sine? Again, we're drawing this thing, sine. So far I've taken into account the shift and the period. Now I do the standard stuff where I cut it in half and then cut it in half again and again. And this is actually quite a pain in the butt to figure out. So let's do it like this. Let's do 7, well, hold on. Pi over 4 divided by 4. So since this is 4 pi, remember all of that is 4 pi. Basically, this is going to be pi, 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 pi. So we can actually figure this out. So pi plus a negative pi over 2 will give us a positive pi over 2. Add pi, 3 pi over 2. Add pi, 5 pi over 2. Add another pi, 7 pi over 2. Woohoo! Okay, that's another kind of quick confirmation that we did this correctly. Sweet, fantastic. Okay, now let's draw the sine. And I like doing this blue. So sine's going to start at 0, end at 0. Halfway mark is going to be 0. What we need to do is 1 minus 1. But again, now we actually take into account the 2. So we're actually going to stretch it vertically up. So the zeros don't move, but instead of being at 1, it's going to go all the way up to 2 and down to negative 2. Sweet, there's our sine. Time for cosecant. So there's the pro tip, right? We drew the graph of sine. But now, remember, cosecant is 1 over sine, so we're going to use where sine is 0 to draw asymptotes. And let's do the final answer in dark blue. So use these points, because 1 over this value oh, I screwed up something. So actually, all right, I'm glad I screwed it up. It's okay to make mistakes. Something looked a little off. So when you do again, remember, we want to do 2 times cosecant. So what I actually want to do is I want to build in that flipping. So I actually want to sketch 1/2. And now the rest is still the same, thankfully. Now think about that as follows. So I'm just going to rescale this a little bit. Okay, so we're actually compressing the sine. So instead of, it's actually stretched out horizontally and kind of pushed in vertically. So it's like really shallow and very stretched out. So it's kind of cool looking. All right, the reason why I put a 1/2 there is because think about it. When I do the reciprocal of this function, and let's actually maybe do the algebra. Let me use this different color. 1 over 1/2. Let's put dots. 1 over 1/2 will actually give us a 2. 1 over sine will give us the cosecant. So that's kind of the trick here. Okay, that looks horrible. Let me not bubble it. All right, but now we're ready for our payoff, which is luckily the asymptotes stay the same, but now try to draw towards the asymptotes as best as you can. So there is our graph. So in the dark blue, we have graphed the function that we were after right here. Whew, intense, but there it is. Alrighty, so what I'm going to do now is I'm going to actually do this last one, but instead of doing the full solution, what I'm going to do is just pause the video, and then I'm going to share the video again and just show you the answer, and then I want you to check your answer. Alright, so let me pause the video. Alright everybody, so, oops, don't know what I just did. Alright, here is the answer to the last problem. So from here, just take a look at the thing. Now my scratch work isn't super neat. I just wanted to get to the graph here, but you can see all the info for the period, the horizontal shift, all of this, just kind of ignore it. It was just, I was trying to figure out all the values. So this is quite a challenge because you remember you have to take your period, cut it up into 4 equal pieces. Also, we're shifting it. So the way I thought of it is I thought of the pi over 2 as kind of my left point. And then I'm going to add 2 pi over 3. So that's going to give me my period. So I ended up at 7 pi over 6 over here. And then to figure out the halfway mark, so what I did is our period is 2 pi over 3, so the halfway mark of that, cutting that in half, is 2 pi over 6, which is pi over 3. So if I add pi over 3 to pi over 2, I get 5 pi over 6, so that's how I know that's the halfway mark. And then also how to figure out where are the asymptotes, that's at the quarter marks. And you can see the cosine kind of hiding in the background. All right, so there we have it. Tough lesson here, but please practice on WebAssign and also ICA, and then ask me questions next class. All right, have a wonderful day. Thank you so much for watching, and keep at it. Do some math. Have a great day. Bye.